Welcome to grade 9 physics. Today we are going to learn something very important, which is equations of motion. Why this topic is so important? You will get it. You will get at least 2-3 questions from this topic. So practice it very well. Write and practice it. You have numericals, you have derivation from this portion. Derivation, definitely you have to write and practice and do as much as numericals as you can. If you have not watched the previous videos related to the lesson chapter 8 motion, please visit my Facebook page, Behrin Tutor. You can find all the previous 7 parts over there. For this portion, we need all the concept we have studied in this particular chapter. So let's begin equations of motion. There are 3 equations of motion. The equations are already given over here. The first equation of motion is V equals U plus AT. The second one is S equals UT plus half AT square. The third one is V square minus U square is equal to 2AS. Don't worry, they are simple. We will take one and we will explain. Okay. But you have to by heart the equation. Suppose you want to do a numerical, you should by heart the equation because that time we cannot derive it. So better you by heart them. Again, once again, V equals U plus AT, S equals UT plus half AT square, V square minus U square is equal to 2AS. Before starting the derivation, let's recall what are each term stands for. You can see some letters over there, V, U, A, T, S. So what are they represent? First we can find out. That would be already, I think you have in the previous lessons, previous videos, I have explained these terms. The first one is V. So what is this V? V stands for final velocity. Okay. V stands for final velocity. Then comes U. U stands for initial velocity. That means when you start your observation, what is the velocity of the object? Suppose the object is at rest, you can take the initial velocity as 0. Suppose the object is already in motion, you have to consider a number for that one. U is initial velocity. Then comes who? Then comes A. A stands for acceleration. What is acceleration? How can we calculate acceleration? These things I have explained in previous videos. Acceleration, numericals related to acceleration. So those who have still doubt on what is acceleration and all, please do watch the video again. A stands for acceleration. Then T. Yeah, T. We know T stands for time. Then comes S. What is S stands for? S stands for displacement or distance. S stands for displacement. Just find out why this S came for displacement. From where? Why the letter? Why we are using the letter S for displacement? Okay. So we have final velocity V, we have initial velocity U, we have acceleration A, we have time T, and S is the displacement. So we have some equations connecting all these physical quantities. So actually these are the physical quantities that is used for describing a motion. So how these physical quantities are related, that is what equations of motion are telling. Okay. So together we can sell this one as SWAT. S-U-V-A-T. SWAT equation, not SWAT. Okay. This S-U-V-A-T is SWAT equations. We can adopt different methods for deriving this equation. But for you, for grade 9 CBSE textbook, we are using graphs for deriving this equation. That is why the title of this particular topic is deriving equations of motion using graphical method. So we are adopting graph. We are using graphs for graphical method for deriving these equations of motion. So we have 3 equations of motion. You have to derive. It can be asked for 3-mark question, and you have to use this equations for solving numericals also. So we will derive each equation one by one. So for that one, we are using graphs. We have studied about 2 kinds of graph. Which are the 2 kinds of graph? distance time graph and velocity time graph. I did already videos related to that one. So please watch this one if you still have doubt on that one. Okay. So distance time graph and velocity time graph. Here we are using velocity time graph. One graph is enough. We are using velocity time graph for deriving equations of motion. So let's see what kind of a graph, because in velocity time graph also we have different three kinds of graph. A straight line parallel to the x-axis, a straight line inclined to x-axis, and there is a graph, a curved graph also there. So what kind of a graph we will be using for this one? Let's check. So here we are going to use a graph like this. We are going to use a graph like this. You can see the graph over here. Okay, so this graph, this is a velocity time graph. Velocity is plotted on y-axis and time is plotted on x-axis. How can we describe the graph? It's a straight line graph. It is not starting from origin, is it? If it was starting from origin, the graph should be like this. But this graph is something like this. What is the difference between these two graphs? This is velocity time graph. This is also velocity time graph. In two cases, actually, the acceleration is a constant or the velocity is changing equally in equal intervals of time. But the difference between them is that in the first graph, when I am starting my observation, the velocity of the object is zero. That means the object is at rest. But in the second case, you can see that when I start my observation, the object is already in motion. So it is initial velocity u is not equal to 0. Here its initial velocity is equal to 0. And all other things are same. Both are in uniform motion, uniform acceleration. So when suppose the question is asked, if the question is like that, derive equations of motion, first you have to draw this particular graph. You have to label the graph velocity time, and I have marked here A, B, C, D, like that. You have to label the graph first. Then you have to give a small introduction about the graph. In introduction, actually we are supposed to mention what are the variables we are using here and what are each variable stands for. For example, how I will describe this graph. Again, I am telling you, don't try to by heart these things, okay? Then, so you can tell this one. Consider an object having an initial velocity u. After a time interval t, its velocity becomes v. Let a be the acceleration of the object, and s is the total distance covered by the object in this time interval t. Again, you can explain in your own words. What you understand from this graph, you can explain in your own words. First, you are seeing an object which is having an initial velocity u. What is happening to this object? After a time t, what happens? The object attains a velocity v. So surely there is an acceleration. Let a be the acceleration of the object. A is not changing, so it is uniform acceleration. Then A be the acceleration of the object. Now we have to include the variable s. S is the total distance covered by the object in this time interval t. So that much is enough. Okay. So first draw the graph, then you have to give a brief introduction. Now we will move to the first equation. The first equation is, so you should have an idea what is your first equation and how. That is why I told you specifically you have to write and learn this one. Don't try to look at it that one. It will not work that way. Okay. So draw a graph, write the introduction. If you want, you can write, but the steps you have to write at least 4 or 5 times. Then only you will get the practice. The first one is V equals U plus 80. This is the first equation I have to derive. So I already have an idea what should I derive. So this is my first equation, V equal to U plus 80. Now look at this graph. Look at this graph. In this graph, I have made a chart, because if the graph is like this, for example, if the graph is like this, in the last class we studied that how I will calculate displacement of this velocity time graph, make it into a closed shape, then the area under this one will give you displacement. The area under this graph, the area under this one will give you displacement. So this one is a triangle. This one is a rectangle. I have to find out the area of the triangle and area of the rectangle. Add them, you will get the total displacement or distance of the object. Here, I have done, this is a graph like this. I shaded all this area. I marked the every corners of this one. So here, this is when the time equal to 0, the object is having a velocity u. After time t, the velocity becomes how much v. Okay. Now I labeled all the parts. Now have a look at this one. What is v represent in this diagram? V is represented by the side BD. V is this distance, this 0 to v. This is the height of V. Here also the same thing, BD, the height of this part is similar to V. So I can write from the diagram or from the graph, BD can be divided into two. What are the two things? DC plus CB. Is it? This is DC plus CB. BD. From the graph, we are sure that BD is equal to V. VD means the total height. Total height means it is finally reaching to V. So V. DC is the initial height. When time was 0, what is this height? This is DC. That means this side is U. So V equals U plus BC. I don't know. I am leaving it like this. Okay. Now, B is equal to U plus BC. Okay. Now, we have to include acceleration in this one. So, think about the definition of acceleration. What is acceleration? Acceleration is change in velocity divided by time. Change in velocity divided by time. Okay. Here, what will be change in velocity? Because initially the velocity was u, finally it becomes v. So what is change in velocity? Change in velocity is v minus u divided by t. Okay, so a equals v minus u divided by t. So what is v minus u? V minus u is equal to a into t. Okay, suppose this one is taken as equation number 1, this one is taken as equation number 2. So B minus U is equal to 80. Okay. So BC, actually now we don't know what is BC. Look at BC. What is BC? The full height is, the total full height is V. Is it? Till here it is U. Then what is this distance? The full height is V. This much is U. So how much is left? That is V minus U. So instead of BC, we can write BC is equal to, because from the diagram, BC is actually equivalent to V minus U. So BC is equal to A into T. Okay. Now if I am putting this one in equation 2 in equation 1, how much I will get? I will get V is equal to U plus A T. You can derive this one in different ways. I am just showing one of this method. Suppose if you want, actually from here itself, you can write A is equal to change in velocity divided by time V minus. If you are rearranging this also, you will get over here. Okay. So the first thing, you have to draw the diagram very carefully. If you want, I will show how to draw it again. So to draw like this, 0 t. We are starting from here. This point is u. Finally, it reaches to the point v. Now I am combining this one down and make this one over here. Label it as you want. 0. If I make it a, b, C, D like this. Okay. So this full length is where first we have to find V equal to U plus AT. So from this graph, V is BD, U is CD. So right, V is equal to, the problem is with BC, we don't know. If you want, you can take from V minus U. But you don't forget to bring acceleration. Acceleration is change in velocity divided by time. That is b minus u divided by t. Actually, the side BC is b minus u. So instead of BC, you can write ET and you can find the first equation of motion. You will find practice it many times, then you will become more confident in this one. Suppose this one is clear for you, this the second one and third one is very easy. Okay, so practice this one. We will continue with second equation of motion the next